Hi everyone, today I'm going to talk about the first lesson of the electrodynamic. First, I will talk about the introduction to the electrodynamics and talk about some basic ideas of the electronics. The fundamental problem the electromagnetic theory hopes to solve is shown in these pictures. Is that we have some electric charges, Q1, Q2, and so on. We can call them the source charges, and what we want to know is what force do they exert on another charge, the capital Q, or we can call it the text charge. The position of these source charges are given as functions of time. The trajectory of these text particles is to be calculated. In general, both the source charges and the test charges are in motion. We can solve this problem by the principle of the superpositions, which states that the interaction between the two charges is completely unaffected by the presence of others. This means that we can first compute the force of the F1 of the Q1 on capital Q, and then we can add the force F2, F3, and so on together, so by the vector form, so that we can get the total force of the source charges on the text charge. This means if you can find the force on capital Q due to the single source charge Q, we are in principle done the problem. Well, this may seem very simple. However, not only the position but also the velocity and the acceleration will affect the answer. Also, as we may learn in the following classes, the speed of the force is limited, which is equal to the speed of light. So we will try to solve this problem step by step. We will first learn the situation when all source charges are stationary. So first, we will introduce one of the basic law in the electrodynamics problem. It is called the Coulomb's law. What is the Coulomb's law? It is said that the law is read in the following form, which F equals 4 pi epsilon 0 and times Q, capital Q, over R squared and times the vector form of the R. In this equation, the constant epsilon 0 is called the permittivity of the free space. In S1 units, where forces is in newtons, distance in meters, and the charge in the coulombs, we will get the epsilon 0 equals to 8.85 times in this form. And also the R is the distance between the source charges small q and the test charges the capital Q. So now we know the basic idea of what force is on the test charges from the source charges. We can try to solve some simple problem. First is that there are 12 equal charges are situated on the corners of a regular 12-sided polygon. For instance, one on each number of a clock face. What is the net force of the test charges Q at the center? Which means we have a clock and there are several equal source charges on the clock. And the test charges capital Q is located at the center of the clock. We want to know the force on the test charges. This is simple according to our Coulomb's law because we have one source charges opposite another source charges. So the total force should be 0 according to the symmetry. And the next problem is if we try to remove one of these charges, for example, we remove this charge, what is the force now? According to the Coulomb's law and the principle of the superposition, we can know that we remove the little q source charges is equal to, we put minus q charges here, and the other we can neglect them. So it will be just like this, and the force will be equal to the form I write. So this is the first lesson of the electrodynamics, and we will go to some try to solve some more difficult problems and tell you more basic ideas of this lesson in the future.